Hello everyone, welcome to Conf42 Quantum Computing 2025 conference. I'm Gayathri Jeganmohan. I am a software engineer at Microsoft and I'm going to talk about quantum powered IoT today. How IoT is going to revolutionized by the quantum computing concepts. So it's going to change the entire intelligence and security in IoT space. So let's get started. So the first thing I want to talk about is, of course, like what is quantum computing? In classical computers, we usually have like zeros and ones. That's how we process it, so that logical is always either zero or one. You can see in the left side, the bit is the logic is if it is exist, it is one, and if it doesn't, it's zero. But in the concept, in the case of quantum computing, in the concept of quantum world, we have something called as qubits. Qubits actually exist in a state of superposition, which means that it can either exist in a state of in between 0 and 1. So it can exist at 0 and 1 at the same time. So what does it actually make an impact? Because in a classical computer, you can see the way we solve the problem is if we are entering a maze, okay, if the left one is blocked or not. Yeah, we keep continuing once we hit the block and then we come back and then we go and try the next route. So it is serialized because of the state of zeros and ones. But in the case of quantum computing, you can compute these things very parallelly because these can exist in the state of both zeros and ones. So in this way, you can calculate or solve a puzzle much faster than a classical computer would do. So there is also something called as entanglement, which is a concept in quantum computing. It is the state of one influence the other. Basically, if you know that this route is going to be all gone, then we don't even try that route. We instead just cancel out those possibilities and then just move ahead so that you don't have to waste time in the compute. So that is how quantum computing is actually different from the classical computing. So, how this is gonna change the IoT space or any other space in general, we'll see that. But first, let's get into how we are gonna focus on the IoT space, which is Internet of Things. So, Internet of Things is like any device that is connected to internet, right? But they also have a huge bottleneck currently. So the bottleneck can be in the categories of intelligence and security, and that's what we're going to target today. So the quantum computing can help in these two areas. So if you want to focus on intelligence first, when we'll get into these two subcategories, which is IoT data analytics and then IoT machine learning. So first is in the intelligence space, let's get into the IoT data analytics. So Internet of Things actually create a lot of data. They are very unstructured. They're very noisy. We don't know where the device is coming, how this sensor data can be made sense because there's temperature coming, pressure coming, and there's like whole lot coming from one factory, and there's like a lot coming every minute and second. So the data is pretty huge. So what does quantum computing can do in this space? What is the main purpose of quantum computing? It can actually analyze like large set of unstructured data. It can make sense out of it and it can actually be more efficient in terms of space and time and memory when compared to the classical computers. And also it can accelerate the machine learning world because machine learning environment has a unique pattern where it needs to do multiple computation at the same time, right? So it can accelerate the anomaly detection and also it can improve the inferencing at the edge. So we'll get into that. And also IoT analytics in the specifically will it improves the pattern recognition because the quantum algorithms are very powerful. HHL algorithm and quantum k-means algorithm, they can find patterns in very large exponential data. It can actually try to look for the main component of details and then it can quickly find a pattern of the data that you're looking for and can give you an answer. So an example would be Volkswagen using a quantum algorithm to detect the traffic flow and also patterns like which area is more densely traffic area in the urban areas, and also it can try to optimize the traffic systems in that space. Other big advantage of in the intelligence space is the anomaly detection. So every time when we go to airports or any when in healthcare, we want to find out the odd man out. In order to do that, we really heavily rely on the machine learning algorithms. So what quantum computing can do, it can scan the multiple possibilities simultaneously And as I said, it can actually rule out all the things which doesn't make sense and then try to get into the solution directly. So it can find out those outliers and rare events much quicker than the classical computers. And it can really help in cybersecurity also. Like in, for example, in Cambridge Quantum, they have developed a highly enhanced anomaly detection. So they have a tool to spot unusual patterns in the network traffic. So anything that happens in large scale IoT, they are able to quickly identify what is the anomaly out there in the network, if there is any fraud happening or anything of that sort. The quantum computing algorithms are much, much powerful in detecting those. So this can help in the IoT space when the network is much more complex and convoluted. So next comes the recommendation system. Actually, quantum-inspired recommendation systems have been proved to be better than the usual recommendation system. So you can see Netflix and Amazon are actually doing some research to explore the quantum-based collaborative methods where it can filter out like the preferences of the user and then try to make it better recommendations. Another very important thing in the security space is the fraud detection. So we know every transaction must be very secure in the case of IoT space. So there is a quantum Monte Carlo method which actually provides more accurate simulations. So it can find out if there is any slight in prediction of any fraud happening that it can actually detect very quickly. And it can actually find out if the fraud has happened, and it can quickly also notify. So Goldman Sachs and JP Morgan are actually investing in the quantum computing because this is going to make a big difference in the future. So next is the bioinformatics. Bioinformatics is like in the genome space, which is basically finding out like how our DNA is and everything, basically studying in more depth of it. So quantum computing is actually used in the genomics sequence alignment. So you can see these different computations are actually happening, which is very complex and heavy, and to understand and study the DNA sequencing. So this is a space where quantum computing can really help. And actually, D-Wave system has actually collaborated with the healthcare startups. So they are doing this DNA analysis workflows, which can actually use the quantum computing algorithms for that. So next comes the main one, which is the quantum machine learning. So in the compute space, in the intelligence space, the machine learning is the biggest deal breaker in the coming future. Because what happens, IoT faces a lot of problem with the respect to inferencing in the edge, because we always rely on the cloud for inferencing, for post-processing. But now the world is changing more towards edge. But we also want a very back-end, powerful way of inferencing at the cloud or somewhere in the outsource space. So that is a place where quantum computing can help. IoT, as I mentioned, it can generate a lot of data, high intensity, high velocity data, and they're very noisy and unstructured. So these limited power and energy at the edge can actually leverage the quantum computing at the back end. So they can increase the need. So basically, real-time decisions can be made if the inferencing is very fast in quantum computing, and that can be offloaded to the quantum computer. And this machine learning just makes the whole process from start to end much easier. So the next part I want to talk about is how it helps in the world of security. Also, I wanted to talk about how the inferencing happens in the edge. So when we can also leverage the help of training, because not just inferencing, right? Inferencing happens in the edge, but in the case of training those models, large data sets, we need quantum support vector machines, as well as kernel estimation. So these are models from the quantum computing machine learning models. They can actually improve the predictive maintenance. They can even like predict before anything happens in a much faster and a much advanced, and also in a very less time, that it can actually be very, really helpful for the predictive maintenance in manufacturing and factories and every other field which needs predictive maintenance. And also it can handle high dimensional sensor data, because right now the sensors are usually zeros and ones, right? So there is some concept called as quantum sensors, which can actually do multiple sensor fusioning. So these kind of multiple fusion sensors can be used in smart cities and smart agriculture, especially also in the autonomous vehicle world. So as I mentioned, backend inferencing is the very key process of machine learning with the help of quantum computing. So when we have a model which is optimized for quantum world, and then the inferencing becomes much easier and much, much faster, and This can really help the whole Internet of Things space using quantum computing. So next is the security. So we have touched based on how quantum computing can really help and break the intelligence space. But the security is another side of the coin, which is amazing because as you see today's classical world, we actually have RSAs, encryption algorithms, which cannot be broken today because the classical computers are beyond that. The keys are very long. It's enough to break. It is very hard to break them. But in the world of quantum computing, RSAs, all these complex security algorithms can be easily broken because they are very good in highly parallelly ruling out all the possibilities and trying to get into the crux of it. So the security becomes weaker as in the introductions of quantum computing. But also when it also comes with an advantage that you can leverage some of the principles of quantum computing and enhance security. So in IoT space, the security is such a big problem because initially it was not designed for our security in mind. So the critical vulnerabilities that we have today, it can be solved using quantum computing. So there are four techniques that are followed, which is defense against quantum attacks, quantum key distribution, as well as quantum random generator, as well as identity management. We'll look into all these four, right? So the first one is the quantum attacks, right? So what happens, as I mentioned, the RSA is AES. AES is the most used algorithm. So these are very vulnerable to Shor's algorithm if we have a quantum computer that can use this algorithm and because it can easily break it can find the keys that were used to encrypt while doing AES and RSA encryptions. So what happens is when we have a quantum, when we have a when we have a very powerful algorithm coming up, we have a quantum safe protocol that can future proof the IoT ecosystems, especially with these long life cycles like vehicles and medical and implants and satellites. They can foolproof the whole entire space when we use quantum computing because it strengthens it much better than RSAs and ECC that we have today. So the next one is quantum key distribution. So right now we have the public key and private key, a combination which will be used to set in one place and authenticate in another place. But in the case of quantum key distribution, we have this method which is a much secure communication, which uses the principle of quantum mechanics. So the way it uses a quantum mechanism is like to make it much more powerful, the way we exchange keys, the encryption keys. This way, the keys are much more secure. And it takes very even more powerful tool of quantum computing to break it. Also, it also guarantees detection of any eavesdropping. If there is any phishing that happens, it can immediately detect and also figure out like where it has happened and notify it very quickly. It also enables unbreakable key exchange. So whenever we have IoT devices from the cloud center and as well as the edge devices, so it enables that exchange to be much more secure. So for example, the secure key exchange between the autonomous vehicle and the roadside units, right? So these things can be tightly coupled when we use quantum key distributions. So the next concept of security is quantum random key generator, which uses quantum phenomena to generate truly random numbers. Because as we agree today, if you use a rand function, it actually generates some random numbers, but they are not truly random. But in order to get a truly random numbers, you can use a quantum method. So it enhances the encryption key strength as well as it can authenticate it much better by using a very stronger key. Example is you can use ORNG for secure session initiation for industrial sensors because industrial sensors, or as I mentioned, they need to first start the nodes and then start communicating the channel, right? So once they start with a proper random generator, they can actually secure it from the start itself. So the last but not least is tamper-proof identity management. So we have signatures today that we sign and send so that it creates that kind of an extra level of encryption and security. But in the case of quantum enhanced authentication method, we have something called as quantum signatures. So these signatures they ensure that devices are verified correctly and they are not like spoofed. And also the communication is traceable. So anything, anywhere, any chain breaks, it can easily detect it. For example, in critical infrastructures, only the authenticated and quantum signed devices can actually send actuated signals. So basically, it can open the wall and shut down the tower. And so all these critical things can be done. So in this way, you're maintaining the identity management much better. So these are all the techniques that we saw in the space of quantum computing as well as quantum quantum computing is doing in the space of intelligence as well as in security. So hope you learned something new. And if any questions, feel free to reach out in LinkedIn. Thank you so much.